Good morning, students. This is the third part of our chapter Light, Reflection and Refraction. In this chapter, we are studying the image formation of concave mirror and convex mirror. To study the image formation, we have to use the four rules that we studied in the last part. So I just revise the four rules. Students, do you remember that four rules that we were studied in the last section? These are our four rules. First rule: a ray incident parallel to the principal axis will move through the focus after the reflection. This is our first rule. Second rule: a ray passing through the focus will move parallel to the principal axis after the reflection. Then third rule: a ray passing through center of curvature will reflect through the same path. And the fourth rule: a ray incident obliquely to the pole will reflect from the pole obliquely by obeying the law of reflection. This angle and this angle must be same. Students, do you remember? We are going to study the image formation of concave mirror using this diagram. So you have to by heart these four ray diagrams first. First, we are studying the image formation of concave mirror. In the last physics lab, we observed that depending upon the distance of object from the mirror, it may produce enlarged, that means big sized, or diminished small image. Do you remember that from the last experiment? Okay. Likewise, depending upon the position of the object, the position of the image is also different. We can place the object in 6 different positions. The positions are: first one, object at infinity; second one, beyond C; third one, at C; fourth one, between C and F; and fifth one, at F; and sixth one, between F and P. These are the 6 different positions of objects. For example, if the focal length of mirror is 20, we can find this focal length by experiments in the physics lab. Okay, and if we place the object in 40 centimeter, means it is placed at C, because we know that F, there is a relation R is equal to 2F. Hence, if focal length is 20, the radius of curvature is 40. Hence, 40 means we are placed at C. And one more case. If it is placed at C, if it is placed in 22 centimeter, it means it placed between F and C, because the distance to the F is 20 and from F to C it's again 20. Hence 22 means we are placed between F and C. Like, we can place at 6 different positions. Now we are discussing each case separately. I already told you that depending upon the position of the object, the position and properties of the images are different. First, we are studying each case separately. First, If we placed at infinity the position of the image at focus, and the properties are highly diminished and point sized, and the image is real and inverted. Next case, if it is placed beyond C, the image will be formed between F and C. The properties are it is diminished, that means image is smaller than the object, and again property it is real and inverted. Then third case, at C, if you place the object at C, the image is also formed at C, and the property is same size, that means object and image has the same size. Once again its nature is real and inverted. Then fourth case, between C and F, if you place image between C and F, the object between C and F, the image is formed beyond C. The property of the image is it is enlarged, and the nature is real and inverted. In this case the image is enlarged at F. If the object is at F, the image is formed at infinity, and its size is highly enlarged, and it is real and inverted. Then the sixth case, between P and F, the image form is just behind the mirror, and the property is enlarged, but it is virtual and erect. Look at this nature. Only in this case, between P and F, students, please remember, I already told you that in concave mirror, only in one case it gives the virtual and erect case. In all other cases it gives real and inverted image. So between P and F it gives virtual and erect image. That means in this case the image is not obtained on screen. Just remember between P and F. Now we are familiar with the different position of the object and the different position of image. You have to by heart these different positions and different properties. It's very simple because the nature is in all cases real and inverted. Only in one case it is virtual and erect, and also this property is also important. At C it has the same size, and between C and F, and at F and between V and F its size is enlarged, and in two cases it is diminished. So we have to by heart this table. Okay, to study this image formation we will study these 6 cases separately. Okay, students, please take your physics note and draw the following diagram as I explained in this video. Very important, study these 6 ray diagrams, 6 image formation as I explained in this video. Okay, very important. It's an important question for your board examination, so you have to by heart the 6 diagrams. Now we are going to the 6 different image formation of concave mirror. Students, first case, we are placed the object at infinity. So where is the position of image? In this case image is formed at focus. What is its properties? Real and inverted and highly diminished, that means small sized. Now we are going to draw the diagram of this case. This is our concave mirror. We are drawing our concave mirror, marking pole and drawing the principal axis and marking the point F and point C, and that distance PF and FC must be same. Now look at the first case. Object is at infinity. To show the object is at infinity, we are putting the dotted line, and here is our object. This is our object. Okay, and the last part we studied that each point in the object will act as point source, and several number of rays will be emerged from this. And for the sake of simplicity, we will take the two rays. Do you remember that? Okay, anyhow, there are several number of rays are emerging from this, but we are using only two rays. And we know that where is the position of image formed? Once again I repeat, the meeting point of the reflecting rays are the points where the image is formed. Hence, look at this diagram. To form the image at focus, I using two rays. First ray, a ray moving parallel to the principal axis. We know that after reflection, it will move through the focus. Once again, I am using one more ray from the object. This is again incident from object, and we know that this is parallel to the principal axis, hence it will also move through the focus. Here in this point, these two reflected rays are meted, hence we know that at this meeting point the image is formed, hence the image is formed at focus. Hence the image of this object is formed at this point, and it is very highly diminished, and its nature is real and inverted. This is our first case, and this is our ray diagram. You have to by heart this ray diagram. In this case we are using these two ray, one moving parallel, and again we are using the parallel ray and meet here, and this position image is formed. I think now it is clear. This is the case 1. Okay, this is the ray diagram of case 1. Now we are moving to the case 2. Now the case 2. From the table, the case 2 is clear. We placing the object beyond C. So if you place the object beyond C, the image is formed between C and F, and the nature is real and inverted and diminished. Also, this two case gives a diminished image. Okay, now we are going to study how this image is formed between C and F. Okay, look at this. In this case we are using two different rays other than this one. Okay, case 2, the ray diagram is as follows. First we are drawing our concave mirror. And drawing principal axis, marking the point P, F and C. Now in this case, where is the position of object? Beyond C. So I am placing a object beyond C. So this is my object beyond C, and this object is upright. This arrow is indicating in upward direction, that means it is standing in upright position. Okay, this straight position. Now the image is formed between C and F. Now to form the image, I am using two rays from this object. First ray moving parallel to principal axis. We know that ray moving parallel to principal axis after reflection will move through the focus. Okay, now I am using another ray. We know that a ray moving through the center of curvature, it's moving through the center of curvature. It must strike on the mirror. That's why I extend this mirror. After, we know that a ray moving through the center of curvature, after it will reflect through the same path, our rule 3. Hence, at this point, this reflected ray and this reflected ray are meeting. Hence, the image is formed this point and it is inverted. That why now the arrow is put in this direction. Okay, it is real and inverted and it is diminished. Look at this. This is object's height is this much and image is this much. That means the image is diminished. Okay, students, we are using two rays. You can make use of any two rays and that reflected ray must meet between C and F, because in this case it is meeting at the image is formed at C and F. So in this case I am using two rays. You can make use of any rays. Anyhow, the reflected ray must meet between C and F. First, I am using this ray moving parallel to the principal axis, and after that will move focus and through the center of curvature. This is our second ray diagram of image formation of concave mirror. Very important. Also write this case also. Okay, now we are moving to the case 3. Students, this is your case 3. Object at C. From the table it is clear the image is formed also at C and the nature is real and inverted and same size. Only in this case the object and image has the same size. Just remember this case, very important case. So we are going to the ray diagram of this case. I am drawing concave mirror. Principal axis, focus C. Now the object is placed at C and we know that image is also formed at C. Hence the two rays reflected must meet at the point C. For the simplicity, to drawing this diagram, very simple method. We know that it has the same size. So I am drawing the same sized image at C, because we know that if the object is at C, image is formed also at C. Don't draw like this. For your to study in simple method, I am using this method. Hence the used rays are, first one, moving parallel. We know that after reflection it moved through focus. This is our first ray. And second ray, a ray moving through the focus. It's a straight line. Okay, will move parallel after the reflection. Here this reflected ray and reflected ray meted here and the image is formed here. We have to draw these two rays. After that we have to draw this diagram, but for the simplicity I am drawing like this, because it should be same sized and it's also formed at C. So to meet these rays at C, it should meet at C. Hence to meet at C, first I drawing the image and after that I am drawing this rays. You can draw this ray first and at the meeting point. The meeting point must be at C and the image should formed at C. That's why I draw first. That's why I draw the image first. Okay. Anyhow, this is this is also a straight line, and there is these two reflected rays meet here. out of these 4 rays, that 4 rules, you can make use of any ray and you can draw this diagram. But if the object at C, the image is also at C, so hence the reflected ray must meet at that point. That is the only thing you have to take care. You can make use of any rays, but after that reflection, the reflected ray must meet according to this condition. You can make use of any rays. Okay, now we are moving to the case 4. Students, what is case 4? Case 4, the object is placed between C and F. Image will form beyond C. Nature, real and inverted and enlarged. Now the diagram. I'm drawing our concave mirror. Principal axis, points P, F and C. I'm placing the object between C and F. This is my object. Okay, and the image should form beyond C. And look at the rays that I am using to form the image. First, we know that ray moving parallel to the principal axis, after reflection will move through the focus. So this is our first reflected ray, and we know that so this is the first reflected ray, and we need one more reflected ray. So to get one more reflected ray, we are taking one ray emerging in this direction. This is in the direction of C. So we know that a ray incident through the center of curvature will reflect through the same path. Hence it is reflected like this, and this reflected rays are meted here. It is formed beyond C. Hence this is our image here. This is the position where the image is formed. It is formed beyond C. So this is our image, and it is inverted. That's why I put arrow in this direction. Okay, and it is enlarged. Look at this object, and this is your image. Once again, I explain the case 4. This is a straight line. This is a straight line. Don't bend here. There is no bend here. So once again, I explaining. I have placed object between C and F, and first ray I take this ray parallel to the. First I take this ray and this ray, and that ray moving parallel to principal axis. After reflection, it moves through the focus like this. And to get one more reflected ray, I use a ray emerge in this direction, because we know that a ray moving through the center of curvature will reflect through the same path, and it is reflected in this direction, and it is reflected in this direction, and this reflected ray meted here, and the image is formed here, and the image is enlarged. There is no bending put in using a scale. Okay, now we are moving to the case 5. Now we are moving to the case 5. At case 5, the object is placed at F. Image will be formed at infinity. Nature, real and inverted and highly enlarged. Now look at the ray diagram. We are doing concave mirror, principal axis P, F, C. We are placing our object at F and the rays. First ray, we are taking the ray parallel to principal axis. You know that a ray parallel to principal axis after reflection will move through focus. So this is our first ray. And the second ray, as in the case of 4, we are taking the ray through the center of curvature. We know that the ray through the center of curvature will be reflect in the same direction, and this is also the reflected ray, and both the rays goes to infinity and it will meet at infinity. That's why the image is formed at infinity and the image is highly enlarged. Okay, we are using these two rays. First ray, incident parallel to the principal axis, move through the focus, and the ray which is moving from through the center of curvature will reflect through the same path, and both the rays will move to infinity and meet at infinity. Okay, this is your case 5. Don't forget to put these arrows to show the direction. You have to put these arrows, otherwise your mark gets reduced. Hence, don't forget to put the arrows also. Okay, now we are moving to the case 6. Now the case 6, object is placed between P and F. If it is placed between P and F, the image is formed behind the mirror. Only in this case the image is virtual, and we know that virtual image is a erect image. So the concave mirror will give a virtual and erect image only in this case between P and F. Don't forget, between P and F it will give a virtual and erect image, and its ray diagram is as follows. Look at the 6th case. This is my object, upward direction, placed between P and F, and the image is formed just behind the mirror. So to show that image formation, I using two rays. Listen once again. First ray, a ray parallel to the principal axis. We know that it will move through the focus after the reflection. And second, I am using a ray which is moving through the center of curvature. We know that a ray moving through the center of curvature will be reflected in this direction. Now look at this diagram. There is a little bit different from the previous cases. Now I am extending this ray from the center of curvature. Also I am extending this ray, and these two rays appear to be meet here. Listen, in this case these two rays are not actually meeting. They appear to be meeting at this point. Such points, two reflected rays appear to meet, are the position of the virtual image. Hence, the virtual image of this object is formed just behind the mirror at this point, and this is actually not going, it is appear to be going. That's why we are put a dotted line, and it is meted here, and this is the meeting point of two reflected rays appear to be meet. Hence the image is formed. And look at this case, this is enlarged image, but it is erect. This is the to the arrow to show the direction, and it is in upward direction. So in this case it gives erect image, and erect image is always a virtual image. Just extend these rays. Okay, we are taking the ray parallel to focus and through the center of curvature. Then we are just extending these rays, and this is the meeting point of this extended ray, and at this point the virtual image is formed. So this is the case 6 between P and F. Image is formed behind and it is virtual. Now we just finished the 6 cases of concave mirror. Now we are moving to the image formation of a convex mirror. In the case of convex mirror, we have to study only 2 cases. First case, the object is at infinity. If the object is at infinity, the image is formed at focus. It is nature is highly diminished, virtual and erect. And the second case, between pole and infinity, only 2 cases are there. Image is formed behind mirror between P and F, and it is diminished, and it is virtual and erect image. Students, please note, convex mirror always gives diminished image, and its images are virtual and erect like our plane mirror. Now we are going to draw the 2 ray diagram of these 2 cases in the following figures. Now we are moving to the image formation of convex mirror. We know that in convex mirror there are only 2 cases. First one, at infinity. The object is at infinity. You know that the object at infinity, its image is formed at focus, and its nature is virtual and erect, highly diminished. Now look at the ray diagram. This is our convex mirror, bulged, outwards, and this is our principal axis, and in this case its F and C is behind the mirror. I just marked the points F and C because this is convex mirror. And now I am drawing my object here. Very simple diagram. To show the infinite in distance, I put dotted line. Now we know that if it is at infinity, the image is at focus. So to show the image is formed at focus, I used 2 rays. First ray, a ray parallel to the principal axis. We know that it will diverge from convex mirror. In the case of convex mirror, it will diverge, and we know that that diverged ray is appeared to be come from F. And once again I am using one more ray, incident parallel to the principal axis, will reflect like this, and it's again appear to become from focus. Here these 2 reflected, these are the reflected rays, are actually they are not meeting. We know that a virtual image is formed when 2 reflected rays are appear to meet. Here these 2 reflected rays are appear to meet here, hence this is the meeting point of this reflected rays. Actually they are not meeting, they are appear to meet, hence the image is virtual, hence it is image is formed at focus. Okay, This is the ray diagram of convex mirrors case 1. Image is virtual. The definition of virtual image is the images which is formed where two reflected rays are appear to meet. Where these reflected rays appear to meet, at that point our virtual image is formed. If they are actually meted, at that point real images are formed. Here its image is virtual, hence this is appear to meet, and this is the meeting point, hence the image is formed here. It is actually is not meeting, it is appear to meet, hence the image is formed here, and it is virtual and it is diminished. This is the object, and we get the image very small, that's why it is highly diminished. Okay, now we are moving to the case 2 of convex mirror. Now the case 2 of convex mirror. The object is between P and infinity. In this case, as in the case of concave mirror, there is no 6 cases like beyond C, at C, between C and F, because all these points F and C just behind the mirror, and we will place the object in front of the reflecting surface. Hence, in this case convex mirror, there is no other cases, only 2 cases we can place, and the second case is we can place between P and infinity. No other cases, because since F and Z is lying just behind the mirror and we have to place the object in front of the mirror. Hence only 2 cases are possible in the case of convex mirror. And the case 2, object between P and infinity, we can place anywhere, you can place anywhere. Okay, and image is formed between P and F, and it is diminished. It's again virtual and erect. Once again, the convex mirror always gives virtual and erect like our real mirror, and it is highly diminished. Please remember, a convex mirror is always give a diminished image, always give. So students, please write one question. Write a mirror which gives always a diminished image, and your answer is convex mirror. Plane mirror gives virtual and erect image, but it should be same size of the object. But convex mirror gives the diminished image in all cases. And it's ray diagram. Look at, very simple, but just take care of it. Okay, first I am drawing a ray incident parallel to principal axis, and we know that a ray incident parallel to incident parallel to principal axis will diverge, is diverged and moves like this. But we know that this diverged ray is come from, it's actually appear to come from this point. There is no bending, it must be a straight line. Okay, use draw diagram using any scale. Okay, so this is the reflected ray, and it is appeared to come from, we know that in the case of convex mirror it is appeared to come from focus. And the second ray, a ray to the center of curvature will reflect through the same path, and now I am extending this ray to the C. So a line to the C will reflect the same path. Hence, this is a reflected ray, and this reflected ray and this reflected ray, it is appear to meet at this point. Between P and F, it is appear to be meet. Hence, its image is formed between P and F, and this is your object, and we get a diminished smaller image of this object. Hence, a convex mirror always gives diminished image. Okay, students, is it clear? This two cases of convex mirror, just a line drawing to center of curvature reflected, and we are extending, it is actually not going, that's why we are putting the dotted line here, and it is meted, appear to meet here, that's why the image is formed at this point. Okay, clear?